Hello everyone, good afternoon and welcome for VXLAN EVPN Group Policy demo. So this is what we have tested in the month of January and the starting of February at the ENTC in Berlin. The test what we have done is based on RFC draft that is called the BEST EVPN Group Policy, and using and then what we have done, we have classified the endpoints based on their traffic profile and pattern, and then we have grouped them. We call it the endpoint groups or the security groups, and each endpoint security group is identified by a unique group policy ID, that is in short called the GPI. And then the BGP EVPN update is going to carry the GPI of that endpoints along with that type 2 advertisement. And finally, we define the policy between the source and destination groups on the VTEPs. And once we have done that, then the policy enforcement is always going to take place on the ingress step. What value we offer using that group policy option on a VXLAN EVPN fabric? First of all, we get that distributed stateless network segmentation capability. So that includes your micro and macro segmentation, both. And there's no need to go and apply the traditional ways of doing the segmentation, be it the private VLAN or the ACL-based approach. And we are also saving the capability and the resources on the firewall, right? Because if we do not employ the private VLANs or the ACLs, then of course we are going to use the firewall for achieving the segmentation, right? So with group policy option, we have the capability of doing the micro and macro segmentation in the VXLAN fabric itself. Okay, so that scenarios what we have tested at this event, that we have the endpoints connected on different leaves in the VXLAN fabric, and we have done the mapping of the classification of the endpoints, the mapping of the endpoints to their respective groups based on their IP information, MAC information, and what port and what VLAN they are connected, right? Finally, as soon as that endpoint comes online, it is going to exchange that ARP message with the VTEP, and then that VTEP is going to do the classification based on the configuration what we have applied onto the devices. And once a VTEP does the classification of the endpoint to its respective group, at the same time it is going to send that BGP EVPN type 2 update advertising that endpoint to the fabric, and that EVPN update is also going to carry the group policy ID for that endpoint. And finally, we have the contracts defined on the VTEPs, and based on that, they enforce the policy. So here's the topology we have worked on. And this test was done between Nokia and Cisco devices. So on the left-hand side, you can see the Nokia VTEP, that is .30, and on the right-hand side, we have Cisco VTEP. We have got two endpoints connected to both the VTEPs, and on the top one, you see in the green one is VLAN 1301, and the IPs are 1.30 connected to Nokia. We are going to map that endpoint to the security group tag 110. And then the endpoint connected onto the Cisco side to the green VLAN, we are going to map it to that endpoint group ID 30. We also have endpoint connected to yellow VLAN on both Nokia and Cisco VTEPs. And then you can see that they are being mapped to the security group IDs 120 and 40 on Nokia and Cisco respectively. On the bottom, you see that the traffic which we want to permit, or we want that traffic to pass through over the fabric between 110 to 30. So that means that the top two hosts connected on Nokia and Cisco, they can communicate with each other. They are part of the same VLAN. The second type of traffic what we allow is the host connected on Nokia on top, talking to the host connected on Cisco, the yellow endpoint. And finally, we allow the communication between the endpoints connected to Nokia and Cisco, which are marked in yellow. And rest all the communication we want to block, that what you see on the right hand side. Okay. Okay, in this test procedure, what we have done the classification of the endpoint to their respective groups on each of the VTEPs. And so automatically, as soon as that endpoint is learned on the VXLAN fabric, through that BGP EVPN update, we also carry the security group tag, so that remote VTEP also knows that what endpoint security group ID a certain host is mapped to. And based on that, each and every VTEP in the fabric, they can apply the policy independently. What kind of traffic patterns we have tested? We have tested IPv4 traffic. We can also do the test. We can also enforce the policy for V6 as well, right? So, but we have only tested V4. We have permitted the traffic between the hosts connected to 2 different VTEPs, and at the same time, we have also tried blocking the different set of hosts which are connected to different VTEPs. And finally, we block the communication between the hosts which are connected to the same VTEP, right? So we have tried to showcase every type of traffic patterns, irrespective where that endpoint is connected in the fabric. So that brings us to the demo part. And before we apply the policy, let me show you the traffic is flowing to the fabric. Right, so here you can see, so this is showing all the traffic. So if you remember that we have 2 hosts connected to Cisco leaf and 2 hosts connected to Nokia leaf, right? So this is the flows between all those 4 endpoints. And as of now, you can see that there are no losses at this moment, right? Because we haven't done any kind of policy enforcement, right? So what we are going to do, we are going to apply the policy, and then what at the end result, we are going to look at that half of the traffic would be permitted and remaining half of the traffic would be blocked, right? So Hamam is going to apply the policy on Nokia, while I apply the policy on the Cisco switch. So one side the policy has been applied, and immediately you can see that some packets are being dropped because the host connected to the same VTEP, they are not permitted as per the policy. Once Hamam also applies the policy, then we are going to see that even the hosts which are connected to different VTEPs, between them we allow certain traffic and we block certain traffic. And by the way, we are just blocking on the complete IP. We have the capability of blocking the traffic based on certain protocols, right? So let's say if you just want to block HTTP, or you just want to allow that, you can also do that, right? So this is what you see. So half of the traffic between the endpoints which are connected to different VTEPs is being permitted and blocked. And then we also have some traffic between blocked is blocked and permitted irrespective of where that host is connected, right? And this is what is the end result, what you can see it here. And then Hamam is going to show some of the show commands just to validate that the mapping of the endpoints to their security group or that group policy ID.
So this is one of the commands. We can see the MAC table for the 2 MAC VRFs that we have. We see the MAC table, as you can see here, that is the group tag has been sent as well. So I have 2 group tag, one local which 120 and one received from Cisco which is 40 for MAC VRF 130.02. And for 1301, we see also one local group tag 110 and one remote tag as well. You see this is for the layer 2, I can see the MAC address. I have another command also to see the IP with the MAC as well.
So this is the place where you can verify that that the mapping of the endpoint to their group policy ID. And this is, or you can in other way, you can say that this is where you can verify the classification of the endpoints.
Yeah, here also, if you wanted to see the IP and the MAC as well, so the MAC and the IP, you see 110.30.120.40, and the IP address here as well, and the MAC. The last thing, if you wanted to see summarization on the IPVRF, there is a command for that as well. Okay. Yeah, you see, this is IPVRF. I can see the group tag also in the IPVRF 110.30, 120.40 as well. So this is all. Also, if you wanted to see log, we have also command for log. View log -f var log sr Linux trace event sr Linux debug, then trace event ACL packet. You see in this also log, you can see which interface is dropped and which interface is allowed, and all the IP address that has been allowed and has been dropped as well.
So for some reason, if you want to debug and want to show that which traffic is being permitted and which is being blocked. So just to conclude that to verify the mapping of the endpoint to the group policy ID and then the contracts and any kind of show and the debug commands that can be very well found on the configuration guides.
Yes, this one is Cisco?
Yeah. That should be 197. If not, I think that we can skip that, right? So anyways, you can go and look at the configuration guides to find out the respective show and the debug commands to verify it.
Okay, thank you very much.
Thank you so much.
Thank you.